Boyle's law. Robert Boyle studied the relationship between volume and pressure of the gas at constant temperature. According to his observations, for a given mass of gas at constant temperature, the volume is directly proportional to its Boyle's law. Boyle studied the relationship between the volume and pressure of the gas at constant temperature. According to his observations, the volume of a given mass of gas is inversely proportional to its pressure at constant temperature. According to Robert Boyle, for a given mass of gas, the volume is inversely proportional to the pressure of the gas at constant temperature. Volume of the gas V is directly proportional to 1 by P, where small n and capital T are constant. Volume and capital T are n and capital T are constant. V is directly proportional to 1 by P, or V is equal to K into 1 by P, or PV is equal to small k constant. PV is equal to small k constant, or P1 V1 is equal to P2 V2. P1 V1 is equal to P2 V2. This is another form of Boyle's law. Boyle studied the relationship between volume and pressure of the gas. Volume and pressure of the gas at constant temperature. Robert Boyle studied the relationship between volume and pressure of the gas at constant temperature. At constant temperature, for a given mass of gas, the volume is directly proportional to 1 by P. V is directly proportional to 1 by P. Our volume is inversely proportional to pressure. So mathematically it is V is directly proportional to 1 by P. Or V is equal to K into 1 by P, where K is constant. Or PV is equal to K constant. Or P1 V1 is equal to P2 V2. That means the product of pressure and volume will not change as long as temperature is constant. As long as temperature is constant for a given mass of gas. If you say for given mass of gas, that means the number of moles of the gas is also constant. So number of moles of the gas is constant, temperature is the constant. In such case, the volume is inversely related to its pressure, or pressure is inversely related to volume. But the product of these two is always constant. This is Boyle's law. Now, if you plot a graph between volume and pressure of the gas, this is volume and this is pressure. So if you plot a graph between volume and pressure at constant temperatures, you will get a curve like this. That means at any given point, P and V are constant. At any given point, P and V are constant. This is Boyle's law. Let us study some problems related to this law. Now, let us do some problems on Boyle's law. Certain amount of gas is present in 500 cc flask at 27 degrees centigrade. At same temperature, if the gas is transferred to a 250 cc flask, what will be its pressure? Once again, certain amount of gas at 27 degrees centigrade exerts 2 atm pressure when it kept in 500 cc flask. When it kept in 500 cc flask. At same temperature, if the gas is transferred into 250 cc flask, what will be its pressure? What will be its pressure? So here in this problem, the main thing that you have to observe is which quantity is constant. So in any problem, just you should observe what are the variable quantities, what are the fixed quantities, what are the variable properties, what are fixed properties. Here, at same temperature, the gas was transferred. At same temperature, the gas was transferred. Whenever you observe that word same temperature, it means at constant temperature. So the law which governs the relation at constant temperature is Boyle's law. You need not think about it. At same temperature means at constant temperature, and you have to use the formula of Boyle's law. Now, see what are the things that were given there. One is 500 cc flask. So initially the gas is at 500 cc flask. When it was in 500 cc flask, the pressure exerted by this gas is 2 atmospheres. At 500 cc gas, the pressure exerted by this gas is 2 atmospheres. That means initial volume of the gas is 500 cc and initial pressure of the gas is 2 atmospheres. So, initial pressure P1 is equal to 2 atmospheres. Initial pressure P1 is equal to 2 atmospheres. Similarly, initial volume V1 is equal to 500 cc. Initial pressure is 2 atmospheres. Initial volume is 500 cc. Now, what the thing that I have done at same temperature, that means at constant temperature, and it was transferred to 250 cc flask. That means this gas was transferred to 250 cc flask. So final volume V2. If it is initial volume is V1, final volume will be V2 is equal to 250 cc. Now what they are asking? They are asking for final pressure. So final pressure P2 is equal to how much? So at constant temperature, certain amount of gas was present in 500 cc flask and it was transferred to 250 cc. Initially, when it was in 500 cc, its pressure is 2 atmospheres. Now you have to calculate its pressure when it was after transferring into 250 cc container at same temperature. Now, according to Boyle's law, initial pressure and volume must be equal to final pressure and final volume. P1 V1 is equal to P2 V2. So P1 is equal to 2 atmospheres and V1 is equal to 500 cc. Then P2 we don't know what is it, and its V2 will be 250. So 2 into 500 will be P2 into 250. So we want to calculate P2. Therefore P2 is equal to 2 into 500 by 250. It goes to 4 atmospheres. So this will be the new pressure of the gas when it was transferred to 250 cc container. Let us do another problem. Such an amount of gas at 750 mm Hg pressure is present in 2 liters flask. If the pressure is decreased to 250 mm Hg, decreased to 250 mm Hg at constant temperature, what will be its volume? At 750 is present in 2 liters flask. If the pressure is to 250 mm Hg at constant temperature, what will be its volume? So here in the previous problem, volume was changed at constant. Pressure was changed. Automatically, volume will also be changed. But at what extent it has to be changed? So here at constant, wherever you find constant temperature, you should first remember or think about Boyle's law. So note down what are the things that were given in this problem. What are the conditions? For certain amount of gas, it means its mass is constant. 750 mm Hg pressure, it occupies 2 liters volume. When it was in 2 liters volume flask, its pressure is 750 mm Hg. Those are the initial conditions. So initial pressure P1 is equal to 750 mm Hg. Then initial volume V1 is equal to 2 liters. Initial pressure is 750 mm Hg. Initial volume is 2 liters. Then final pressure P2 is 250 mm Hg. Then final volume according to Boyle's law, we know that P1 V1 is equal to P2 V2. P1 is equal to 750 into 2 will be equal to 250 into V2. V2 is equal to 750 into 2 by 250. This is 3 times. 3 2s are 6. Sorry, 6 liters. So, at 250 mm Hg pressure, the final volume of the gas will be 6 liters. So, here in this problem, once again, see, certain amount of gas at 750 mm Hg pressure is present in 2 liters flask. If the pressure is decreased to 250 mm Hg at constant temperature, what will be its volume? So, certain amount of gas is taken in a container and it exerts some pressure. Now, keeping temperature constant, what they have done? They decreased the pressure. The decrease of pressure is possible at constant temperature when volume was increased. So, you have to find out the final volume. So, initial pressure is 750 mm Hg, final pressure is 250 mm Hg, initial volume is 2 liters, what is the final volume? So, initial pressure into final initial volume must be equal to final pressure into final volume, that is Boyle's law. P1 V1 is equal to P2 V2. We know P1 is equal to 750 mm Hg and V1 is equal to 2 liters. Whereas final pressure P2 is equal to 250 mm Hg and V2 you have to find out. P1 V1 is equal to P2 V2 or V2 is equal to P1 V1 by P2. That is 750 into 2 by 250. So, this 250 will go 3 times in 750, 3 into 2, 6 liters. So, the final volume of the gas is 6 liters. This is the final volume of the gas. Now, here we have another problem. Certain amount of gas is present in 750 cc flask at 2 atmospheres pressure. At constant temperature, if it is transferred into 500 cc flask, what will be its pressure? What will be its pressure? So, here certain amount of gas is present in 750 cc flask at 2 atmospheres pressure. So, the initial conditions, the pressure is 2 atmospheres and volume is 750 cc. At same temperature or constant temperature, means temperature was kept constant and it was transferred to 500 cc flask, the volume was changed. So, automatically temperature will also be changed, but the product of temperature and volume will remains constant as long as temperature is constant. So, this is Boyle's law. So, the thing that was given in this problem, initial volume V1, initial volume V1 is equal to 750 cc, initial pressure P1 is equal to 2 atmospheres, final volume V2 is equal to 500 cc and you have to find out final pressure. According to Boyle's law, P1 V1 is equal to P2 V2. that is the product of pressure and volume, initial volume should be equal to final pressure and final volume. So P1 is equal 750 into 2 initial will be equal to 500 into P2. So P2 is equal 750 into 2 by 500. So 3 250s and 2 250s. This 2 cancel. The resultant pressure will be 3 atmospheres. So the final pressure of the gas is 3 atmospheres. So this is Boyle's law. So once again, certain amount of gas is present in 750 cc flask at 2 atmospheres pressure. At constant temperature, if it is transferred to 500 cc flask, what will be its pressure? Certain amount of gas was present in 750 cc flask at 2 atmospheres pressure. Keeping temperature constant, it was transferred to 250 cc container. What will be the new pressure of the gas in the new condition? So when anything was changed at constant temperature, you should first think about Boyle's law. What Boyle's law says? At constant temperature, for a certain amount of gas, the product of pressure and volume remains constant, whatever the changes that you have taken. Now initial volume is 750 cc and initial pressure is 2 atmospheres. And now the volume was changed to 500 cc. Automatically pressure will also be changed, but this product will not change. So P1 is equal to 750, V1 is equal to 750, P1 is equal to 2 atmospheres, V2 is equal to 500 cc and P2 is equal to, you have to calculate, P1 V1 is equal to P2 V2, P1 is equal to 750, P1 is equal to 2 atmospheres, V1 is equal to 750 and P2 is equal to, you have to calculate, and volume is 500 cc. So 750 into 2 is equal to 500 into P2. Therefore P2 is equal to 750 into 2 by 500. So here 750 by 500 is nothing but 3 by 2 and 2 cancels. So 3 atmospheres remains there. So the pressure of the gas in new condition will be 3 atmospheres. Certain amount of gas is present in 5 liters flask at 3 atmospheres pressure. At constant temperature, if it is transferred to 2 liters flask, what will be its pressure? Here also, for certain amount of gas at constant pressure, certain amount of gas, N is constant, T is constant. It follows Boyle's law. So what are the things that were given? Initial volume is 5 liters and initial pressure is 3 atmospheres. And it was transferred to 2 liters flask, that is final volume is 2 liters. What will be the final pressure? So initial volume V1 is equal to 5 liters. Initial pressure P1 is equal to 3 atmospheres. Now final volume V2 is equal to 2 liters and you have to find out final pressure. So P1 V1 is equal to P2 V2. Now you have to find out P2. So P2 is equal to P1 V1 by V2. That will be 5 into 3 by V2 is equal to 2. So this will be 2.5 into 3. It will be 7.5 atmospheres. So the final pressure of the gas when it was at 2 liters flask will be 7.5 atmospheres. So these are the problems that can be solved by using Boyle's law. Now there are certain other parameters are also given with the same Boyles. Let us verify it. See, here we have something different problem in the same concept that is involved in Boyle's law. Certain amount of gas is present in 2 liters flask at 5 atm pressure. Certain amount of gas is present in 2 liters flask at 5 atmospheres pressure. And this flask is connected to 4 liters evacuated flask. What will be its pressure at constant temperature? What will be its pressure at constant temperature? Here in the previous problems, we observed that the gas is transferred to certain volume. Transferred, the term transferred was used. But here in this problem, the flask was connected to another flask, completely evacuated flask. No gas is present in it. So here you have a gas in 2 liters flask. Let it be this flask. This is 2 liters volume. Now you have certain amount of gas in this flask. Now this flask was connected to another flask which is fully evacuated, and its volume is 4 liters. So the difference is, here initial volume and final volume was given in the previous problems. Now in this problem, what they are telling? One flask was connected to another flask, an empty flask or fully evacuated flask. So one flask was connected to another flask. The final volume should be the sum of these two volumes of the two flasks. The difference is, in the previous problems, it was transferred, the final volume was given. Here the final volume is not given. Only the change in the volume was given. Connected to another flask means the change in the volume was given. The change in the volume, the increase in the volume is 4 liters. Initial volume is 2 liters. So final volume will be 2 plus 4, that will be 6 liters. The total volume should be 6 liters. That is only the difference. The rest is same. Just the wording is different in this problem. Initial volume is 2 liters and it was connected to another flask of empty flask of volume 4 liters. So the final volume will not be 4 liters. The final volume is the sum of the volumes of two flasks, that is 2 plus 4, that is 6 liters. So initial volume of the gas V1 is equal to 2 liters. Initial pressure P1 is equal to 5 atmospheres. At constant temperature, this flask was connected to another flask of 4 liters. So final volume V2 will be 6 liters. 4 plus 2. And what will be the new pressure? P2. So P1 V1 is equal to P2 V2. P1 V1 is equal to P2 V2. Then V2 is equal to P1 V1 by V2. So P1 is equal to 5 atmospheres and V1 is equal to 2 liters by V2 is equal to 6 liters. So 3 times 5 by 3. That means 1.67 liters. That is the final pressure, 1.67 atmospheres. Sometimes they may be asked like this. When the flask was connected to another flask, means you have to add the volume of the two flasks to get the final volume of the gas to be occupied.